Welcome to this explainer. Today, we are throwing on our detective hats to solve a cinematic cold case that's been lingering for over 2 decades. Now, if you're familiar with the classic film The Green Mile, you know it leaves us with this profound, lingering question about the fate of the main character, Paul Edgecombe. But instead of just kind of sitting around wondering about his fate, we're actually going to use the hard numbers provided by the film's established timeline to calculate exactly how long Paul will live. We're going to break down the math step by step.
If you know the story, you know this haunting final line. Paul Edgecombe, now an incredibly old man, reflects on the supernatural gift imparted to him and to a little mouse named Mr. Jingles by John Coffey. It's just a brilliant piece of writing, really, because it's not just an emotional reflection on the curse of outliving everyone you love, it's an actual solvable math equation. The film practically dares us to do the calculations. It perfectly sets up our mathematical cold case.
Okay, let's dive into this. Our objective for this explainer is simple but absolutely fascinating. We're going to crack this case using only the cold hard facts provided by the source material. No guesswork, no wild fan theories, just pure structured logic.
Part 1. The Evidence and Establishing the Facts.
Look, every good detective story starts with gathering the raw data. Before we can run any calculations, we need to know exactly what we're working with. So, the core story takes place in the year 1935. At that time, Paul is 44 years old. The present-day framing narrative, where old Paul is actually telling the story, takes place in the year 1999. Because exactly 64 real-world years have passed between 1935 and 1999, old Paul's actual chronological age in that timeline is exactly 108 years old. Keep those numbers 44, 64, and 108 locked in your mind.
Part 2. Scenario 1. The mouse math.
We're going to test the most obvious hypothesis first. It's the calculation most of us probably tried to quickly work out in our heads while watching. So the crucial point is how the supernatural energy affected the mouse. According to the source material, Mr. Jingles was roughly a year old during the events of the movie, and he dies in the year 1999 at the ripe old age of 66. Now, the average lifespan of a standard mouse is about 3 years. If we divide 66 by 3, we discover that Mr. Jingles lived 22 times a normal mouse's lifespan. Step 2 is applying that exact same multiplier to Paul. If we take an average human lifespan in the US, which is roughly 78 years, and multiply it by that 22 times life extension, what do we get?
1,716 years. Yep, you are seeing that correctly. If Paul's lifespan multiplied at the exact same rate as the mouse's, he would be wandering the Earth for nearly 2 millennia. Honestly, I think we can all agree that borders on the absurd.
And here's the logical flaw with that. On one hand, we have this mathematical projection of over 1,700 years. On the other hand, we have the reality of what we see on screen, a visibly fragile, aging 108-year-old man. Paul is clearly aging much faster than a 1,700-year timeline would ever suggest. If he were going to live for 17 centuries, he wouldn't look like an old man at age 108. He'd essentially still look like he was in his late 20s or early 30s. So consider this myth officially busted. We need to find the real math. Let's move to our next section and see how this builds into something much more accurate.
Which brings us to Part 3. Scenario 2. The Biological Reality.
Let's pivot to a much more scientifically plausible approach. Instead of using a mouse multiplier, we're going to ground our math in the actual, visible biology of the actor portraying Paul. While we established earlier that Paul is chronologically 108 years old in 1999, his body is not acting like 108-year-olds. We need to determine his biological age. To do this accurately, we look to the actor who played old Paul, Dabbs Greer. When he filmed those scenes in 1999, Greer was exactly 82 years old. So, for our mathematical model, Paul's biological age, how old his body actually looks and functions, is 82.
Now we have everything we need to calculate Paul's exact rate of aging. Let's walk through it together. Step 1. We know that 64 actual calendar years passed between the events in 1935 and the story being told in 1999. Step 2. We look at his biological aging. In 1935, he was 44. In 1999, his body is biologically 82. 82 minus 44 means his body only experienced 38 years of aging. Finally, step 3. We divide those 38 biological years by the 64 actual years. The result? An aging rate of 0.59. Paul is aging 0.59 times slower than a normal human being.
Now, what's really interesting about this is how we predict his end date. To figure out how much time Paul has left after 1999, we again look right back to the real-world actor, Dabbs Greer. Greer passed away at the age of 90.
Since Paul was biologically 82 in 1999, that means his body has 8 normal biological years left to live, 90 minus 82. But remember, Paul doesn't experience normal years. We take those 8 biological years and divide them by our aging rate of 0.59. That gives us 13.5 actual calendar years left for Paul to live.
Part 4, the final payoff, and Paul's true timeline. We've done the hard detective work. We dismissed the flawed mouse multiplier and calculated his exact 0.59 aging rate. It's time for the final mathematical reveal, 121.5. By taking Paul's chronological age in 1999, which was 108, and adding his remaining 13.5 actual years, we finally solved the mystery. Paul Edgecombe will live to be exactly 121 and a half years old. And this brilliantly illustrates his entire life journey mapped out. He experiences the profound events on the Green Mile in 1935 at age 44. He tells his haunting story 64 years later in 1999, chronologically aged 108, but biologically holding steady at 82. And finally, after outliving his friends, his wife, and even Mr. Jingles, his supernatural longevity runs out. Adding 13.5 years to 1999 means Paul would have finally passed away in the middle of the year 2012, at the age of 121.5.
We've solved the math, but the numbers leave us with something much deeper to consider. The core theme of the Green Mile presents extreme longevity not as a blessing, but as a deeply isolating curse. The pain of watching the world and everyone you love pass you by. Paul's biological clock ticked in nearly half the speed of the rest of the world. So, looking at the reality of those 121.5 years mapped out, would you even want that kind of time? It's a heavy thought to end on, but understanding the exact math somehow makes Paul's long, slow walk on his own Green Mile feel that much more real. Thanks for joining me on this explainer. I really hope this breakdown provided you with a completely new perspective on a classic story.